You're being asked to write a third degree Taylor polynomial. Make sure you understand that when you're asked for the third degree Taylor polynomial, that means you need the x minus the center cubed term and all lesser degreed terms. I'm going to put just kind of a dash there for a number. You have to account for everything all the way down to the constant when you're asked for the third degree Taylor polynomial. It's not just the single term that has the cubed. I was trying to get the eraser. Now it says about x equals 2, so that means that this is the formula we're using, the Taylor formula about x equals 2. You are told the value of f of 2, the first derivative and the second derivative, as well as the third derivative. So you're pretty much just taking those numbers and filling them into this spot. You want to be familiar with the fact that the first term is the function's actual value at the center. The first degree term is made up of just the first derivative multiplied by x minus the center. And then the formula really kicks in with second derivative at the center over 2 factorial x minus center squared, and third derivative over 3 factorial x minus the center of 2, and that should have been cubed. And now it's just an issue of substitution. F of 2 is negative 3. The first derivative is 5. The second derivative is 3, and 2 factorial is 2, so I'm just going to write 2. And then the third derivative is negative 8. 3 factorial is 6. You can, in a free response answer, leave 3 factorial as 3 factorial, or you can write it as 6. You can choose not to reduce the fraction of negative 8/6 if you don't want to. That's just up to you, how far you want to go with the simplification, but it's not necessary. So this is the answer to the first part that is asking for that third degree Taylor polynomial. Then the next thing it's asking is for you to use it to approximate f of 1.5. So at that point, you're just saying f of 1.5, and it's very important to do squiggle equals. The AP test has in the past taken off points for not doing the squiggly equal to, because you need to show that you understand that if you chop the polynomial off at a certain degree term, it is an approximation. So you can simplify as little or as much as you want with these numbers. If I plug in 1.5, that's just going to give me negative 1/2. Simplify at your own risk. I'm going to reduce the fraction to negative 4/3. You are allowed to call it a day on that. As long as that number is plugged in, you've got it. Did you take out the times 5? I neglected. And that's why it's such a danger. Oh. And then you can simplify it to a number or just leave it. I'm going to pause, if I can figure out how to pause. I thought that I was supposed to be able to pause this, but apparently I can't.